All right, this is the PAQi. Stands for Picture Acquisition and Inspection. And how did we get here? LM3 Technologies and its founder, Michael Waltz, have been doing machine vision over 20 years. Michael developed his first configurable vision system in the early 2000s when the technology was emerging as a reliable form of visual inspection. After years of working on complex vision applications, LM3 set out on a challenge to make machine vision less time-consuming, more reliable, and more affordable. Traditional machine vision has its limits. If for nothing else, it requires a huge amount of time, consuming trial and error by machine vision experts to piece together several small inspection steps and tune their parameters to achieve the goal. Large vision system suppliers provide higher-level tools to package a set of steps to achieve a high level of accuracy across a common set of applications, but these tools are targeted at mass market and do not always achieve the best results, thus requiring customization. PAQi is LM3's answers to the challenge because it utilizes artificial intelligence to replace the human function of first piecing together or customizing the steps to formulate the best inspection algorithm, and then uses the amazing processing power of today's TPUs, GPUs, and CPUs and chipsets to fine-tune the parameters associated with those steps to achieve the best results while continuously testing better ways to achieve the goal in seconds versus days, weeks, or months. The rule of thumb we use is if a human can see objects or defects on an image, the PAQi system will learn how to find the objects or defects by simply providing it samples to learn from. Because the detectors LM3 deploys are non-proprietary, we can offer this technology at an affordable price, allowing smaller companies to compete with larger competitors regarding quality control. Coupled with our low-cost hardware, AI-based visual inspection is no longer cost-prohibitive and ready for use by all. So what is PAQi? PAQi is a full-featured vision inspection system that incorporates proprietary software with high-resolution industrial cameras to achieve a customizable interface to your equipment and devices. PAQi can store pictures of components for future evidence and documentation, detect parts presence, such as screws in an assembly, detect cosmetic defects, such as scratches and dents, detects injection molding defects, detects metal weld defects, detect production equipment anomalies such as debris in a mold cavity, detect alignment issues in assembly. Why would you choose it? We designed PAQi to be mounted as a standalone package or within a control cabinet as part of a manufacturing line. PAQi works with up to 4 industrial cameras up to 42 megapixels. The PAQi software is designed to be user-friendly with no coding needed, allowing even an inexperienced technician to configure the system for many types of applications. So how does PAQi work? The initial setup can be achieved within minutes. The first step is to acquire images of your manufactured components. Once images are acquired, they are processed through a program LM3 provides to label the images. After labeling the images, they are fed into an online training tool called QC Hero, using AI-based detectors that generate a trained detector capable of correctly identifying the labeled objects or images. The trained detector is copied to PAQi, and a single button calibration is used to associate the detected objects with the expected objects in the images. This determines pass or fail. PAQi then operates on the line to do automated inspection. Below we have a chart that demonstrates the advantages over traditional methods for doing inspection, whether they be human inspection, sensor-based inspection, or traditional machine vision. Our customers include some very large corporations and some small ones as well, including Cooper Standard, Magna, Lear, Yanfeng, Bayer, Steelcase, CK Technologies, Cascade Engineering, and AGS, to name a few. Here are the general system costs. A 10 megapixel single camera system starts as low as $5,500 with quantity discounts available. Additional industrial cameras, up to 6 total, can be added to the system for $750 each. Because PAQi can do image acquisition using any kind of a digital camera, direct show, and an inexpensive webcam can be used to reliably acquire images. Industrial types of webcams run at less than $150 each. In order to do physical measurements, you will need to purchase a one-time NIVBA license at approximately $850. QC Hero detector training is a pay-per-use web-based system at $20 per hour. A complex object detector usually trains in less than 3 hours or $60 per session. LM3 can be hired to do customization. LM3 provides affordable accessories including lighting controllers, I/O breakout boxes and cables, buttons, and LEDs to round out the system and avoid the need for high-cost integration. Contact us at sales@lm3tech.com or 312-376-8305 to receive a quote for your application or to receive a demo unit. In this slide is an overview of enabling inspection. So you have the PAQi controller, which is used to interface with the station, acquire and store images, and host inference models, the detector. And then it also has programming in place to calibrate against the expected set of objects or images. We provide a labeling program called Label IMG-LM3, which allows you to label your images, generate labels automatically, copy labels, augment images, and package together the labeled images in preparation for upload to QC Hero. At QC Hero, you're able to manage all your images by detector name and train the detector, and of course export a trained detector for use by PAQi. The PAQi main components inside the controller are an Intel NUC Windows 10 Pro version with a solid-state M2 internal hard drive and up to 32 gigabytes of RAM. You can optionally load National Instruments VBA-I to do traditional machine vision and measurements, and the system contains an onboard PLC which allows you to customize the interface with your production line or machine. On the exterior of the PAQi controller are the ports for adding barcode scanners, cameras, network connections, mouse, keyboard, and monitor. As shown in this slide, you can connect the LAN port to the plant network to store images remotely and port into the machine for remote support. All internal components are fused for protection, and digital I/O can be connected to the M12 port, such as sensors, lights, solenoids. The ring light on the control box itself indicates the status of inspection, and an external power supply is used to power the unit so that any type of AC voltage can be used, whether you're operating in the United States or overseas. Additionally, the video output port allows you to connect a monitor for applications where there's human interaction with the system. Of course, you can connect buttons and barcode scanners, and we also print labels on pass or fail. And then there's the ability to connect to the Wi-Fi, and of course there's Bluetooth support. By default, the PAQi allows for up to 4 USB cameras to be connected, but the software will allow for 6 total cameras, which can be done by connecting GigE cameras through the network port. This slide shows how you can connect various devices to the PAQi to run complete inspection in your production environment. Regarding its history, PAQi was developed in 2017 as a way to create a containment system in a production environment. The goal was to have a camera, device, or system that when triggered would simply take photos and save them locally or over the network. The second goal was to link the photos to the production for traceability. This was initially designed to be triggered by the scan of the product serial number, resulting in an image stored by that serial number. The purpose of this was to have traceability pictures for the customers as proof of assembly and assistance in problem solving. Many other cases were similar, and the pictures were named by a unique serial number commonly referred to as warranty photos. The third objective was to have a unit that could break the price barrier of traditional systems. Current vision systems are expensive, and by reducing the cost of hardware, customers can deploy machine vision analysis across a wider range of applications, leading to a quality-controlled standard. The system would have to be simple enough and low cost in such a way that if there was a failure, it would be quicker to unplug the unit, install a new unit with the program, and be back in production very quickly. The system would have to be able to handle multiple cameras as well. The system would have to connect to a robot and be mobile. The system would have to be able to change parameters and programs on the fly to deal with different products. Finally, the system would have to provide easy-to-use configuration tools to avoid consuming plants personnel's time, which is better spent on production. The PAQi functionality overview. 1. The simplest function is for PAQi to take photos and store them to a file. The PAQi waits at a start position for a trigger, and once received, scans the barcode of the part being inspected. We then acquire an image and store it to either the network or locally and report the results to the station. 2. Another way to use PAQi is for traditional machine vision inspection, as shown below. In this example, a set of steps are put together to inspect for the presence of the cap on the spray bottle. In the leftmost picture, you can see that it's able to find the edges of the cap in reference to the top of the bottle and verify that the cap is present, resulting in a pass. Using the same steps on the right image, you can see that the program is unable to find the edges of the cap and therefore fails the inspection. To continue, in inspection mode, PAQi waits for a trigger as usual, scans part number or generates a part number and serial number, acquires an image, passes the image to either VBAI for traditional machine inspection or to a detector for it to return the objects found based on how the detector was trained. Those results are returned to PAQi, at which time PAQi determines pass or fail. The image is stored along with the results, and the monitor is updated to report the results. Since the PAQi has multiple camera capabilities, it can take warranty pictures with some cameras and analyze pictures from other cameras. There are cases installed where 2 cameras are taking warranty pictures and 2 cameras are taking pictures and analyzing them, whether using a detector or VBAI. In some cases, it makes most sense to mount a camera to a robot and scan around a part, especially if it's a large part and you want to get very close-up pictures of different sections of the part. This slide explains how that interaction works. In the latest version of PAQi, you have the ability to set up jobs and count parts as they're being inspected and automatically stop production when the number of parts exceeds or is equal to the expected count. In the production count mode, the PAQi can sense when the cycle time of production exceeds the expected cycle time and require the operator to select a reason for the downtime. This allows us to track downtime across the entire job and report OEE metrics. Under all circumstances, PAQi stores results to a SQL server, whether it be local or one on your network. All individual step results, whether it be from VBAI measurements or detectors, are stored by their score or their measurement value in reference to the image that was taken. This allows for more advanced analysis of production performance. PAQi is used for a multitude of inspection requirements, including features presence, defect detection, color classification, physical measurements, and traditional machine vision operations, and a combination of object detection and classification, as well as object detection and object measurement. In the following slides, I'm going to go over some of the use cases of PAQi. To start, I want to provide an example of how QC Hero for deep learning detector training works. QC Hero is an online training tool which allows you to train multiple detectors simultaneously. This tool called QC Hero provides a means of continuous improvement in detector management. Using this tool and the configuration tools available in PAQi allow you to be completely self-sufficient and manage the entire PAQi system on your own. With that said, use case 1 that we are showing is defect detection on molded parts. This molded part is approximately 24 by 24 inches in size, so a rather large part, and we're inspecting for defects using a 5 megapixel camera. So this is a 2-cavity mold. So we inspect the left side and the right side in series. This is showing cavity 2 as a good part. In this image, there's a large short. This is most likely during the startup of the press. Quite easy to detect. Smaller defects, such as this little short on this bracket, on this part, are also caught by PAQi. In addition, PAQi can detect splay. So in this case, these brackets towards the center and this smaller bracket that we just showed with the short have splay on them, and the part is rejected. The advantage over other systems is that one camera can be used to inspect the entire part. Traditional machine vision systems are unable to detect variable defects anywhere on the part because usually they have to be pointed in one spot of the part where you expect the defect. We all know that molding produces defects in completely unexpected locations at times. We also do not require special lighting because the detector training system is able to change the lighting for different scenarios. And this is rather fast. It's not for high-speed type production, but we can do an inspection of a large part like that in less than 3.5 seconds, which is plenty of time for molding machines. Plus, the nice thing about PAQi is that the system gets smarter the more you train it. The next use case is parts presence for hog rings. As some of you, anybody that knows hog rings, this is a pneumatic-based tool, and there's no way to sense for sure that the hog ring has been properly assembled to the part. So in this case, we have a bolster with an airbag in it, so it's a safety-critical part, and it's necessary to know that all 5 hog rings are in place so that the airbag deflects properly. Notice the ability to detect the hog rings on lighter colored material versus the darker one in the previous image. Also, we're able to mount a single camera, also 5 megapixel in this application, on the overhead structure to look down at the part as the operator is working on the part or assembling the hog rings. You'll notice in this slideshow that the operator's assembling the hog rings and eventually clears the field of view with all 5 hog rings in place, and the inspection passes over here on the far right. One of the main advantages of our system versus traditional machine vision systems is the ability to use one camera at a long distance to detect multiple objects. Typically, integrators would use up to 5 separate cameras to detect the 5 individual hog rings, but then there's also the issue of where you place them to stay out of the working area and still be able to see the hog rings well enough to do inspection. Use case 3 is very similar, but it's sensing multiple fasteners versus multiple objects of the same type. So this detector has been trained to sense screws, clips, brackets, bug screens on a very large grill. Now this is a very large field of view, over 60 inches wide, using a single 10 megapixel camera, also on the overhead structure so that it's out of the way of the operator. So the advantage of this system, again, is that we can use one camera out of the operator's working area to detect multiple small objects, and we can also use it to do layered assembly, such that we verify that the operator completes certain tasks before moving on to the next steps. In this use case, we're doing something similar again with parts presence, but in this case it is black push pins on a black substrate. And we're also detecting several of these, 7 push pins on both the left and the right hand side of the part. Now, this is a very large semi-truck bumper, so being able to do this with one camera is quite amazing. Notice here that the system is able to detect a missing push pin where the red box is shown, and in this image it's able to detect that one of the push pins is not pressed in all the way. In use case 5, we're doing detection of defects on metal welds for a seat frame. So here we're looking at the left side of the seat frame and the crossbar weld, which was done by a robot in this case, so it's very clean. But then if we go over on the right side, it's common to have reworks, manual reworks. So this is a manual rework. You can see how it's kind of bubbled in the middle. But we're able to train the detector to say that this is okay. So this little inconsistency in the middle is trained into the system to be okay. Next, we go back to the left side with a burnout, and PAQi is able to detect that burnout. That's a pretty large failure, so to be expected. But we can also sense pitting, which is a lot more of a subtle type of defect. So again, there's no special lighting required for PAQi. We're just using standard overhead lighting. In this case, there's multiple settings on the overhead lighting. So we train the system to detect the difference in lighting and what to consider okay and not okay. Again, we're also mounting the camera overhead so it's out of the way of the operator during assembly. Use case 6 is the use of PAQi on a GP12 station for final inspection, which involves both parts presence and defect detection. In this image, PAQi controls the entire station, and there are 3 total cameras. One here, and then one overhead looking at the center of the part. As mentioned earlier, PAQi comes with accessories that allow you to connect buttons, sensors, lights, solenoids. So in this view, you have PAQi with a I/O breakout box and a separate lighting controller. For this application, we need to precisely verify that pieces of foam and clips are present on 8 parts introduced to the station. And in this case, we do use special lighting to make sure that we have a very good view of the end of the parts. So as shown in these images of the actual GP12 station running, we verify that a medium-sized piece of foam is present, a small piece of foam, black foam, is stuck to the top of the medium-sized foam, and that these clips are present in the right location. In this particular application, we're able to find these objects, verify their presence, then feed them into VBAI to do measurements from the center line of the clip to the extreme end of the part to verify the clip is in the right position considering it's a datum. This application also works with the operator to allow for correction of not found objects that are okay for shipping to the customer. So in this case, if PAQi were to find that the foam did not meet its standards on part number 3 from the top, the operator could go and correct that by visually inspecting the part and pressing on the defect to change it from bad to good, or vice versa. Because all of the inspection data is stored to SQL, it is especially useful to run reports after production completes on GP12 to report all failures found to work the system upline to improve the manufacturing process. Using PAQi for GP12 or safe launch applications saves money in several ways. It reduces the number of human inspectors by doing basic inspection of parts present on multiple parts at once. Improves quality control to shorten the containment time. It eliminates any customer paybacks. Reduces scrap and is up to 1/5 the cost of non-comparable but competing vision systems. This in essence reduces your launch time and saves you money by having a shorter period of containment. Plus, the system gets smarter the more that you train it, and allows you to dedicate your human resources to the production system itself and improving it to reduce the number of defects that reach the end of the line. The last use case I want to go over is inspecting parts within a shipping box. So as you see, these are backs to office chairs of different colors, and they're sequenced during production so that Herman Miller, in this case, receives parts in sequence to do their assembly. So in this application, PAQi is used to find each object, even though it can be in the box at different angles, left and right, twisted. So first we find the parts, and then we take the found section of that part and feed it into a classifier to classify the color of each part and compare it against what is expected in the box. So if, for instance, the second from last part from the top is a blue part versus a black part, the inspection fails and the operator is notified to correct the bad part in the box. One of the advantages in this case is that PAQi, because it has an onboard PLC, can control the entire station, including feeding the box into the light booth. Another advantage of PAQi in this case is its ability to control the entire station, because you can connect a monitor, mouse, keyboard, barcode scanner, and control motors, solenoids. PAQi can be the central controller for the entire station, which it is for this particular application. So now I'm going to get into some of the standard features of VBAI in the case where you would want to do physical measurements. So VBAI can be used for edge finding, color inspection, pattern and geometric matching, gauging, golden template comparisons, image filter and frequency analysis, image segmentation, and then system coordination as well. So, this is pretty standard stuff as far as traditional machine vision goes. It's been around for a long time. All systems operate similarly. So I'll kind of go through this fairly quickly. So here are the functions in VBAI that are strung together or sequenced together to make up a complete inspection. The advantage of the detectors is that the machine does all of this for you. But if there are cases where you need to provide physical measurements to your customer, we use VBAI in combination with the detectors. So here's some different applications where VBAI is being used to track objects, verify the correct machining of pulleys, verify there's no surface defects on plastic parts, OCR, barcode scanning, and the like. That completes our slideshow. Feel free to contact LM3 Technologies at sales@lm3tech.com or at the phone number listed.